So let's go over how we find R1. So if we use Ohm's law, we could find R1. And what we're going to need to know is the voltage across that resistor as well as the current going through it. Well, the current going through that resistor, R1, is going to be the same current that goes through the rest of the circuit. Looking at R3, I see voltage, I see resistance. So therefore, I know that the current is going to be voltage divided by resistance. V3 divided by R3. And that's going to be 6 volts divided by 3 ohms, 2 amps. So it's going to be 2 amps going through the whole circuit. So now I know what the current is going through R1, and that's also the current going through R2. So I could find the voltage going across R2. The voltage drop across R2 is going to be voltage equals the current times resistance. So V2 equals current times R2. And that's going to be the 2 amps times the 9 ohms. And that's going to be the 18 volts. So I could use another rule we learned about the voltage drops around a series circuit to find V1. And that rule is that V total equals V1 plus V2 plus V3, and if there were more or less, we would add them if need be. But here we have 3 voltage drops will equal the total. So 48 volts is going to equal V1 plus 18 volts for V2 plus 6 volts for V3. So we have 24 volts so far with the 18 and 6. So V1 must equal 24 volts. So if we know we have a voltage drop of 24 volts across R1 and 2 amps going through it, we could find R1. Using Ohm's law again, resistance equals voltage divided by the current. Therefore, R1 is going to equal V1 divided by the current. 24 volts divided by 2 amps. R1 must equal 12 ohms.